All right. 1.1, solving one-step equations. I'm going to do this similarly to how I did in class, where it's more of like a review, since you should know these by the time that I took over the class, but still just as a refresher in case you don't, and I'll still explain things in between here and now, just slightly faster than as if you had never seen these before. So let's say, for example, we have x plus 4 equals 6. What is this? What does that mean? Multiple parts to this. We have the entire thing, which is called an equation. If you want a full formal definition, an equation is a statement where two expressions are equal. What does that mean? We have the statement. Statement's the big old thing. Or two expressions. We have x plus 4 and 6 are equal. Equal. And an equal sign. So the statement is the whole thing. The equation is the whole thing, where two expressions are equal. Now, most of the time when you have things that look like this, an equation, the instructions will say solve the or this equation. And then it'll show you the equation. How do you do that? What does that mean? Well, solving the equation means to find a solution. A solution to an equation is a value that makes the equation true. So basically you need to find what this variable can be or should be. What is a variable? Real quick, a variable, something that changes. It can variable. It can vary, or it can change. Sometimes it changes, sometimes it doesn't. In math, it can be any symbol, not even a letter. It doesn't have to be even a letter in the English language. It could be a cat instead. And it doesn't matter. It can be anything. But most of the time, it is X, Y, Z, A, M, P, any of the letters of the alphabet. So you can represent something that can change, that can vary, or just something that we don't know. And in this case, this is something that we don't know. So when it says solve the equation, it means find a solution. Find what that value can be. You might be thinking to yourself, okay, so it's just something plus 4 equals 6, 2. Right? Duh. 2 plus 4 equals 6. You just think about it. You don't have to do any math or anything. But there is a systematic way to do this. I'll move this to the side. There's a systematic way to do this, especially as things get harder and more difficult, where sometimes you can't just think about it and then end up finding what the value is supposed to be, what the solution is. The systematic way of doing it is using something called inverse operations. They are operations or things that you do that cancel each other out, that undo each other. For example, addition is the inverse operation or the opposite of subtraction. If you add something and you want to remove it or take it away or just have 0, then you take it away. You subtract. I give you 4 marbles. I want you to have 0. I take away those 4 marbles. I give, I add, I take away, I subtract. Multiplication is the inverse operation of division. That one's a little bit harder to explain, where now you have multiple groups of things, and then the opposite of that is dividing those groups or separating those groups into things. A little bit hard to explain, but just remember those are the inverse operations, or things that cancel each other out, things that are opposite of each other. Now, how do we use those? We use those in this case because whenever it says solve the equation, you're trying to figure out what the variable is. This is the same thing as trying to figure out x equals something, something equals x. Same thing as isolate the variable. Only having x on one side. Only having x on one side. That's the goal. Here, there's x on one side of the equal sign. It's over here. What else is here? There's a plus 4. How do we get rid of that plus 4? We do the inverse operation. We subtract. So we subtract 4 from both sides. 4 minus 4 equals 0. 6 minus 4 equals 2. And now we have this plus 0 over here. What does plus 0 even do? It does nothing. 1 plus 0 equals 0. Or 1 plus 0 equals 1. 1 plus 0 equals 1. It doesn't do anything. So it's as if it's not even there. X equals 2. You can just get rid of it. So if we want to double check that what we found was a solution, you can just plug it back into the variable and see if the same thing works out. X plus 4 equals 6. See if 2 works. 2 plus 4 equals 6. 2 plus 4 equals 6. Does 6 equal 6? Yes. So that is a solution to the equation. That's always our goal, basically. Isolate the variable, because that's the fastest way to figure out what x, or whatever you're trying to solve for, can be equal to. Now, I'm going to run through new page. I'm going through a bunch of different examples. I'm going to go kind of fast, but I'm still going to talk through it. So, let's say we have x minus 7 equals 10. I'm going to write down, move this over a little bit. I'm going to write the inverse operations. You can always write this as top of your page if you can never remember. You just have to write it once, and then that's it. Inverse operations. Addition and subtraction, multiplication, and division. So we have x plus 7 equals 10. X on one side. We have to do the opposite of what is happening with the x. What's happening with the x is being subtracted by 7. What's opposite of subtraction? Addition. So now we have to add 7 to both sides of the equal sign. Think about it like there's a line down the equal sign. Whatever you do on one side, you have to do to the other side. You have to keep things equal, because that's what the equals means. Very quick example. Let's say you have two different people. They need to be equal to each other of what they have. One of them has 2 flowers. The other one also has 2 flowers. We want to give this person 3 flowers. But to keep things equal, you have to give the other person 3 flowers too. So now they both have 5 flowers, and that stays the same. Because they're equal. You have to keep them equal. Whatever you do to one side, you have to do to the other side. So that's why we add 7 on both sides. We already know that goes to a plus 0, so I'm just going to cross it out. They cancel out. What's left here is x equals 10 plus 17, 17. And like I said, if you want to, you can always double check by putting it into the original equation, see if it works. 17 minus 7 equals 10. 17 minus 7, 10. 10 equals 10. Perfect. Another one. X minus 6 equals negative 10. Subtraction going on here. Opposite of subtraction. Addition. So we add to both sides. 6, 6. Those cancel. X equals negative 10 plus 6. Real quick refresher if you struggle with remembering if things are going to be negative or positive. Alright, that's just in the middle. If we have a positive plus a positive number, it's going to equal a positive, obviously. Like 2 plus 3 equals 5. They're both positive, positive 5. If we have a positive plus a negative, or a negative plus a positive, what is that going to be? Well, what you do here is you subtract the numbers, and then the sign is the bigger number. What does that mean? For example, let's just say in this case, we have a negative number being added to a positive number. Negative 10, positive 6. So you just subtract the numbers like normal. 10 minus 6 equals 4. And then the sign, is the bigger number. Which number is bigger, the 10 or the 6? The 10, right? So is 10 positive or negative? It's negative. So the answer is going to be negative. So negative 10 plus 6 is negative 4. So over here is negative 4. Now what happens if you have a negative plus a negative? Then you just add the numbers. Sign is negative. Like for example, if we have negative 6 plus negative 2. You just add the numbers like normal. 6 plus 2 equals 8. And then you just slap a negative sign on it because both of them are negative. So just fast and easy rules if you can never really remember what's going on. I will tell you to keep in mind that when you have a scenario like this, I'll remind you, subtraction is the same thing as adding a negative. So for example, 10 minus 7, you might know, oh, that's 3. That's the same thing as 10 plus negative 7. And then that means from here you have a positive plus a negative, positive plus a negative. That means you subtract the numbers and it takes the bigger sign. So you subtract the numbers like normal. 10 minus 7 equals 3. Which one's bigger? 10, positive number, positive, so positive 3. So just a reminder, subtraction is the same thing as adding a negative. Just in case you get confused sometimes. So anyway, back to the problem. X equals negative 4 here. Try another one real quick. X plus 10 equals negative 2. We have, what are we solving for? The x. It's on this side of the equal sign. What else is here? The plus 10. Opposite of plus, subtraction. So we subtract 10 from both sides of the equal sign, both sides. And you might see you have a line across the entire bottom instead of two separate lines like there is here, just to make things, just shorthand, to make it faster instead of drawing two different lines. They're different from division, so just be careful on that. But those cancel out. X equals, oh my god, a negative minus a positive number. What do? There's no minusing here in these rules. If I just write this out over here, negative 2 minus 10. If you remember what I said, subtraction is the same thing as adding a negative. So if I rewrite this out, subtraction is the same thing as adding a negative. Now you can see this is just a negative plus a negative. Negative plus a negative, you just add the numbers and you slap a negative sign on it. So 10 plus 2, 12, negative 12, because they both have negatives. Negative 12. Now let's switch the format a little bit and also maybe switch up the letter. So we have 9 equals, I don't know, b plus 4. Same exact thing. We're solving for the variable. We're solving for the thing we don't know. What side is it on? It is on this side. But it's not alone. We want it to be alone. What else is here? Plus 4. Opposite of plus, minus. So we subtract 4 from both sides. 5 equals b. Another example. Let's try a little bit of a... not just yet. Let's do another example. X minus 17. What side is the variable we're trying to solve for on? This side. What else is here? Minus 17. Opposite of subtraction is addition. Plus 17. Both sides. Those cancel. X is equal to, this is 25. If you want to write things nicely and in convention, the variable, or what you're solving for, is on the left side instead. So you just swap the order that they're in. Because 25 equals x, the same thing as x equals 25. So if you want to be nice to me, that's how you write it. Let's try another example. Let's do 7 plus x equals 20. Now you might be thinking, ooh, there's a plus here, which means it's plus 7, so you subtract 7. Technically, you're right, but thinking about it in the wrong way. It's not subtraction because there's a plus here. It's subtraction because there's an invisible plus here. You can think of it like this. Anytime you see a number without a sign in front of it, you just put a plus. Because it's if it's a positive number, right? If it's a positive number, there's nothing there. If it's a negative number, there's a negative sign. So just to make things simple, you can think of it like that, where you have an invisible positive. Or there's something called the commutative property that applies to addition and multiplication, where basically if you can swap the orders of things. Like, for example, 2 plus 3 is the same thing as 3 plus 2, right? Both of them are 5. Sorry, commutative property. And same for multiplication. 2 times 3 is the same thing as 3 times 2. They're both equal to 6, right? So you can do the same thing here. If you really want to, you can swap these because it's being added. X plus 7 equals 20. And then from here you can see, okay, it's a plus 7, so I subtract 7. Or you can see from here, with that invisible positive, it's a plus 7, so you subtract 7. Either way, subtracting 7 from both sides, x equals 13. Write that nicer. Okay. Another example, a couple more examples of just addition, subtraction stuff. Let's do negative 13 equals x plus 8. You can see we have addition, so we want subtraction. So we will subtract 8 from both sides. Those cancel. Negative 13 minus 8. Same thing as negative 13 plus negative 8. Adding negatives, so it's going to be a negative answer. You just add them like normal. 13 plus 8, 21. And like I said, with the convention, x equals negative 21. Another example. Negative 12 equals 7 plus x. You have an invisible positive here, so you subtract 7, both sides. That cancels. X equals negative 12 minus 7, negative plus and negative. And it's just going to be negative 12 plus 7, 19. X equals negative 19. Now, that was all just addition and subtraction. Now we're going to do multiplication and division. If I have something like this, 7x equals 14. There's a letter next to a number. What does that mean? I will tell you, 7x is the same thing as if they're being multiplied by each other. Same thing as 7 times x. That dot means times, not a decimal. It's a little bit higher than a decimal. It's in the middle. Times x, or 7 times x, parentheses, if you know about them. Same thing as multiplication when they're right next to each other, right? There's kind of multiple reasons why we don't just write the multiplication sign, because if we did that, we'd have 7 times x. Kind of hard to tell that's times. Is this one a times? Is it just an x? Is this one a times? Is it just an x? And then what happens if we add a whole bunch more things in there of just like 7 times x times y times b times z? Which one of these are x's? Which one of these are multiplications? You don't know. So instead, convention has decided it's just going to be as if there is no multiplication there at all. You just write them next to each other. So this is 7 times x. 7 times x equals 14. Opposite of multiplication. Division. So we divide both sides by 7, by the number we want to get rid of. Those cancel. X equals 14 divided by 7, 2. Real quick, I'll run over why these cancel in case you don't know, because that's kind of important to know, to understand. So, if I have 7 times x equals 14, we have the whole thing divided by 7. And we're just going to focus on this side, so I'm going to stop writing this side for a second. 7 times x divided by 7 is the same thing if we separate those out. 7 over 7 times x, right? 7 over 7 times x. Because you can just separate them out like multiplication. For addition and subtraction, you can't separate them out like that. Just as a heads up. Like if you had 7 minus x divided by 7, that you'd have to keep the denominator there. It's 7 over 7 minus x over 7. But for multiplication, you don't have to, because it's the same thing as if I did either here 7 times 1. So if you split it down the middle, it's over 1. Or same thing as doing this, where if you combine them, 7 times x across the top and across the bottom, 7 times 1, same thing as here, 7 times 1, anything times 1 is itself, 7 times x over 7. So, but anyway. So you can either think about it like, hey, I have a times 1 at the bottom here, or when I separate them out like this, it is x divided by 1. Because if you remember, anything divided by 1 is itself. What's 2 divided by 1? How many times does 1 go into 2? 2 times. Or alternatively, what times 1 equals 2? 2. Anything times 1 is itself. So, in this case, that's where this x turns into over 1. We can always just add it there. 7 over 7. How many times does 7 go into 7? Once. This is also asking, same thing as over here, of what times 7 equals 7? 1. So we have 1 times x over 1, which is x. And then anything times 1 is itself, so just x. And so from here, that's how we get back. Those cancel because there is, quote unquote, 1 on the top and 1 on the bottom. 1 on the top, 1 on the bottom, 1 on the top, and 1 on the bottom, which turns into a 1. And then whatever is left over is what it turns into. Whatever is left over is what it turns into. So, quick explanation on that. Running through some more problems. We have 4x equals negative 20. You know, these are being multiplied, so you divide by 4 on both sides. 1 on top, 1 on bottom, those cancel out. X equals. Ooh, we have a negative. What are some negative rules for multiplication and division? For multiplication and division, I'm just going to write multiplication for the examples, even though it's both multiplication and division. If you have a positive times a positive, or a positive divided by a positive, that's going to equal to a positive. Positive 2 times positive 3 is positive 6. If a positive times a negative, or a positive divided by a negative, or a negative times a positive, or a negative divided by a positive, that's going to equal to a negative. Negative times a negative, or negative divided by a negative, that's going to equal a positive. So basically, whenever the signs are the same, you have 2 positives or 2 negatives being multiplied or divided by each other, then the answer is going to be positive. Same sign as positive. When they are different, one of them is positive or one of them is negative, so one positive or one negative. When they are different, then the result is going to be negative. So if they're the same, positive. If they're different, then they're negative. Here we have one negative and one positive. There's no sign in front of it, so we just have an invisible plus. A negative divided by a positive is a negative. And you just do it regularly. 20 divided by 4, 5. X equals negative 5. I'll run through a bunch more examples. Negative 5x equals 15. Same thing as negative 5 times x. So you divide both sides by negative 5 to get rid of that whole thing in one go. Negative 3. 15 divided by 5 is 3. Positive divided by negative, negative. Another example. 16 equals 2x. Divide both sides by 2 because they're being multiplied. Those cancel out. 16 divided by 2 equals 8 equals x. That's all that's left. Convention, write x on the left side. box your answer so I know where your answer is. Another example. -4 equals -2. Choose a different number. A. Solving for A. -2 times A. So you divide both sides by -2. What's left is A. Negative divided by a negative. They're the same sign, so the result is positive. I'll just do really small here. 4 divided by 2 is 2. A equals 2. That's multiplication stuff. Now let's do some division stuff. Let's have x divided by 5 equals 2. This bar is like a fraction bar. That means division. What's the opposite of division? Multiplication. So we multiply both sides by the number we're trying to get rid of, 5. Those cancel for the same exact reason. I'll write it out over here. 5 times x over 5. This is the same thing as if you had over 1, right? Because anything over 1 is itself. Because it's multiplication, if I just combine the two together, 5 times x, 1 times 5. Commutative property, I swap the denominator, 5 times x over 5 times 1. And then I separate them again. 5 over 5 times x over 1. And then we run into the same thing. 5 over 5, anything over itself is 1, times anything divided by 1 is itself, and anything times 1 is itself. So that's how this turns into this, which then turns into this. And then what's left on this side? 2 times 5 is 10. Run through some more real fast. 4 equals, let's do m divided by 6. Solve for m. Multiply both sides by 6. Those cancel out, so now we're just m on this side. 6 times 4 is 24. M equals 24. Run through some more. Let's see. -6 equals y divided by 4. Another way of writing multiplying both sides by something, or just writing multiplication in general, is to put whatever you're multiplying by in parentheses. That's the same exact thing. So that's what you want to do, you can do that. Negative times a positive is a negative. 6 times 4 is 24. Because what's left is y. Y equals -24. Now, slightly trickier one. X divided by 4 equals 7 divided by 4. What do? Well, the steps that you do is always reliant on trying to solve for the variable in the first place. We have a divided by 4 here. Opposite of that, multiply. So you multiply both sides by 4. And if you remember why these cancel, because there's 1 on top, 1 on the bottom. Same exact reason as why up here. There's 1 on top, 1 on the bottom. 1 on top, 1 on the bottom turns into 1. 1 on top, 1 on the bottom. 1 on top, 1 on the bottom. Oops. 1 on top, 1 on bottom, top, bottom, turns into 1. If they're the same. Same thing as over here. 1 on top, 1 on the bottom. 1 on top, 1 on the bottom. Because that's the same thing as this, right? 1 on top, 1 on the bottom. 1 on top, 1 on the bottom. So these cancel for the same exact reason as these cancel. I'll write the whole thing out for you if you really want me to. 7 times 4 over 4 times 1. 7 times 4 over 1 times 4. Separate them out again. 7 over 1 times 4 over 4. 7 times 1, 7. That's what's left over after canceling those out. And that's what's left over here after canceling those out. X equals 7. That's it. Same exact thing as if you had even negatives. Like -8 over 3 is equal to, I don't know, p over 3. You multiply both sides by 3. Cancel out because 1 on top, 1 on the bottom. P equals -8. Another example. Let's do negative 7 equals v over 4 being divided by 4. So we multiply by 4 on both sides. Those cancel. V is equal to negative times a positive, negative 7 times 4 equals 28. So v equals negative 28. So in the end, all these with the addition, subtraction, with the multiplication, with the division ones, all you have to remember is that you are isolating the variable. You're getting only what you're trying to solve for on one side. And to do that, you do inverse operations. Find out what else is on the side of the variable you're trying to solve for, and then get rid of it using inverse operations. So that's one-step equations. They're called one-step because all these only took one step. Either you subtracted or added, and that's it. You divided, and that's it. The one step. Divided, one step. Multiply both sides. That's only one step. And then you got the answer. So, obviously, if you have any questions, you can try emailing me, talking to me next time I see you in class, etc., etc. See ya.